So we've just written out a text file, and you'll notice that I didn't actually show you evidence that it's there. You have to take my word for it, but not entirely, because I could have gone to the actual disk directory and showed you the file is there and the content is there, but instead we're just going to go into the reading a text file. We'll read from that same file, and you will see that all the text we just wrote out from Shakespeare is now in that file. We're going to use Python itself to verify its existence by now reading a text file. The basic process is the same. We will need to open the file, then we'll do the I/O operations, and finally we will close the file. But now we do a slightly different operation, obviously. Instead of using the write method, we will use the read method. But here's a kind of cool feature of Python. There's more than one way to read a text file. There's at least two different ways, and they're both useful. I'll show you both. You can read as much text as you want, including you can read the entire text file as one big long string by using the read method. It will read the entire file, included all the new lines, so they will automatically be printed with the new lines in the proper place. You can also read in a text file as a list of lines, so this goes back to our list technology, which is very, very useful. So when we read a text file, we can optionally use the readLines method, and the readLines method will give us a list, will give us a series of elements. Each one of those elements is a string representing a line of text. But remember, if we read in individual lines that way, we will get the trailing new line, and we will need to strip that away, or at least be aware of it. So let's do the really easy way. First, we can open the file. It needs to be the same name, obviously. Now we open in read mode instead of write mode. We then call upon the read method and print what we read. Finally, we close the file. And what could possibly be simpler? Read the entire text file with one operation, print it. It's really simple. And again, this is another way in which Python does things that in another language might require 2 or 3 times the space. But this is really pretty simple with Python, and I'll show you how easily this works. So we will go to idle. We will enter this program. First, open this text file, stuff.txt. And it's stuff.txt because that's what we called it when we wrote that file. But now the mode, which is also a string argument, is now R. So this should open the file. And by the way, it didn't complain, and that's important because that means Python went out to look for that file. When it's read mode, it must find a file that already exists or it will complain, and it will generate an error. The next lesson, by the way, will learn how to handle those errors. But it's happy. It found the file. It opened it. It's therefore in existence, and now we just need to read what's there. So I'm going to create a variable name called file contents. That's a pretty long name. I could use a much shorter name, but I'm using file underscore contents because it's descriptive. Again, the way Python is, I can use any variable name at any time. I'm using a more descriptive name here. And file underscore contents is going to store, if we're successful, the entire contents of this file. And if I say f.read with no arguments, by default, it will just read as much of the file as it can. So therefore, it will read the entire file. So file contents equals f.read. It should read all the contents in this text file. Well, it did. And it put it in this variable, file underscore contents. Now let's just print it. File underscore contents should have everything in that file. We say print file contents. Let's see what happens. There it is. To be or not to be, that is the question. Is it not? That's exactly what we wrote. Finally, we say f.close, and that's important because that will free up the file so that other applications can use it. So, therefore, I've used Python itself to prove to you that the writing to the file was successful because we read the same file and it shows us exactly what we wrote. So we wrote to be or not to be, closed it, opened it for reading, read it, printed it on the screen, closed it. But now let me show you, there's another way, slightly more verbose, but sometimes you might want to use it. This will do the exact same thing. This will have the exact same end result. But with this approach, what will happen is all the individual lines of text, so that's everywhere we have a line of text that's ended with a new line, starts a new physical line, everywhere we have a line of text, it will actually be a separate element in a list. And sometimes putting all the lines of text in a list is very convenient, allows us to operate on each of those elements differently, and sometimes you might want to do that. So even though this is slightly more verbose, it's the same end result. The thing to keep in mind, though, is that with this approach, when we read individual lines into a list, each of those lines is going to come with a new line. And because the print statement adds a new line of its own, we could end up with extra new lines. We don't want that, so we're going to strip the new line and then print it. So remember that this text file was opened, we read it, and then we closed it. So now we have to reopen it so that we can read it again. And again, we open it the same way. We use the R string, which means read mode. It's happy with that open operation, so it seems to be fine. Then I'm going to read all the lines of text into a list by saying read lines instead of read. So if I said f.read, it's going to read everything into one big string. If I say f.read lines, it's going to read it into a list. But again, we can print everything in the list very easily by using what? By using a for loop. Because remember what a for loop does. If I say for s in stir list, what that will do is it will execute the statement block one time for each element in the list, and it will set s to the current element as we're going through the list. So this just means step through the list. And what we want to do is we want to strip the new line from the list element. So s is actually an individual element as we're stepping through. We strip the extra new line, which we don't want in this case, and just print the string. There it is. Produce the same result. What did it do? It read the whole file. The only difference is that in this case, it put everything in a list. So as I pointed out before, some programs will want to break down individual lines of text into a list for various reasons. We didn't need to do it in this case, but it showed that we can take that approach if we want. And finally, you do want to close the file. Once again, closing the file allows other applications to access the file so that we don't just leave it open and no one else can access it. So we just do f.close when we're done. Now, before we end this lesson, there's one other thing that's important to keep in mind that will possibly be on the MTA exam. It's a very useful feature of file operations. Python supports a with keyword for the use of file operations in particular. It's also used with other things, but the file operations is the most common. The with keyword can be used to open a file, get back a file object, although the order of the syntax is a little different. We then go do the same things we would have done anyway. And the beauty of the with keyword is that closing is handled for us automatically. So this saves us at least one line of code. It's also more efficient and more reliable because if we use this approach, that even if something goes wrong, the with block will automatically close the file for you. It's actually a better way to write code. But as you look at the example here, it's very, very short. It's 3 lines, open a file, we read the file contents, print it, knowing that the with keyword will handle the file closing for us. So this is a really nice feature, very, very slick. And it is worth learning the syntax for with. So basically what you do is you use with, which is a keyword. Now we put in the open statement, and at the end we say as, and then we have our file object name. I've been using F because it's so short and convenient. By the way, you can name the file object anything you want, right? You can name it file object X, whatever you want. I've been using F. Remember, Python, basically any name for any kind of data that includes file objects, but it can be as short as F. And if you use with, you have this simplified syntax. And the beauty of it is I don't have to close it. I've actually written an even simpler little code block here, and it's amazing what it does in 3 lines. And finally, before we end this lesson, it's also useful to think about what can go wrong when you work with files. And that will become very, very important in the next lesson, because things went right this time, but there's all kinds of things that could go wrong with files. And therefore, you actually really do have to anticipate those errors if you want to write professional code. So first of all, when you open a file for reading, the file must already exist. If your file doesn't exist, this causes something called a runtime error or an exception, which we're going to get into later. And when you open a file for writing, well, it doesn't have to exist, so it's not as tough a condition, but there's still things that can go wrong. The file name must be a valid file specification that the operating system recognizes. It has to have the right characters. It can't have funny characters. So it must be a valid file specification. It has to be able to say, oh, that's a valid path name if you include it. And the file name has to be something the operating system is happy with. So things can go wrong even if you open something for writing, and you have to anticipate those errors. And then finally, something I haven't mentioned before, but this is something to keep in mind. When you open a file, it must be available for I/O operations or input-output operations. Sometimes files may exist on your disk that don't have read permission or don't have write permission. So those are just some of the things that can go wrong. I wouldn't anticipate those necessarily unless you have a complicated situation where the user's entered random file names. But as you write more and more sophisticated code for commercial applications, you're going to have to think about these error sources, but fortunately, we will talk about that a lot in the next lesson. So finally, this is universal among programming languages. It's always a 3-step process. I do have to open a file where I specify the file name, a path name if you need it. Then we do the I/O operations, and finally we do have to close the file so it frees it up for other programs. But as we just saw, you can use the with keyword, which will reduce some of what you have to do. It will make for shorter code, and it's actually more reliable code. So it's worth studying the with keyword syntax. Go back and look at that, and then experiment with it on your own, I would suggest. And then finally, it helps to be familiar with the text file modes, which are R and W. But remember, you can do T for text mode. That's never necessary because that's the default. And B you would use for binary mode. And then again, you use R for read, W for write, and A for append. And these are all available. I've just done simple read and write for this lesson. But that should give you a very good taste of how you read and write text files in Python. And there's a few steps, but once you learn them, it's basically a piece of cake.